Good evening, everybody. First of all, I am thanking MBSS as well as INIS to give me the opportunity to present a paper on a case study. Here I am taking up about 3-4 projects and how that it has been executed, and then really as commercials, that how it is being successful. So we just move on to the subject. Current activity in structural steel is driven by commercial structures, and how is the topic that I am addressing now. First of all, commercial structures, if you define what is commercial structures, in terms of buildings, if you take other than residential building, like offices, hotels, malls, convention centers, hospitals, and say institutional, educational institutions, all these things comes under, say, commercial structures. And if you take overall survey, in the as high-rise buildings, if you take which has been taken up a few years back, the number of buildings which are being in concentration in Asia is the heaviest, which is almost about 33% per se in the whole say construction industry as in the whole world is concerned, of which if you take as cities, within 25 cities in India, we are there on 23rd, and it's about 470 plus numbers of towers are being, they estimated that it is going to be constructed, and of which if you take as commercial structures, almost everything is commercial structures except few which are residential, and that is all in our present testing. The developers are right now started moving into residential buildings in structural steel, whereas major portion, almost about 90% of the structures are commercial related items. And if you take as material, if you see the graph or the chart which we are presenting here, initially most of the structures have started with steel in way back in 1930s, and later completely it has been taken up into concrete, and the later part, that merging of two structures together, two material together, that it has been taken up as composite. And presently, according to the high-rise levels, whether it is 20-story or 30-story or 40-story, the material which is really beneficial being analyzed, and most of the cases as high-rise buildings that we have started using with composite structures. And as if you see the even subject which is related to sustaining of the growth, development that meets the needs of the present without compromising the ability of the future generations to meet their own needs, which is actually like a green building concept, where right now structural steel can be a major thing, as our earlier speakers discussed, mostly into reusage of the material, where steel is the best option comparing with any other material. Now in terms of commercial buildings, we just go through all the projects which are being displayed is being constructed by us in that. Offices, if you take one of the high-rise building in say Singapore, Republic Plaza has been done by us. Then the Tiara Towers and the Burj Al Arab, right now the tallest building in the world, 828 meters, is also done by us. And if you take the offices, like the top left is Almas and Petronas Tower, and the most inclined building as of now in the world, Capital Gate in Abu Dhabi, and Tornado Tower in Qatar, and of course Al Shams. All these structures have been constructed in composite structures, mainly by taking columns either as encased column or as say with concrete filled tubes, and as of course the beams are being steel and the metal decking are being used for the decking system, where we have eliminated the formworks. And if you take Rose Rota, in terms of hotels, we have taken up. So Rose Rota, on your right, on your left, the last, which is 75-story building in Dubai, and the middle one is Kingdom Trade Center in Saudi Arabia, which is also a hotel. And of course, the last one is Burj Al Arab, is also a 7-star hotel made up in a man-made island. All are being used extensively with structural steel. And in terms of convention centers, if you take Putrajaya Convention Center in Malaysia, which is almost 105-meter unsupported long span structure, and in fact, the designers have done the design based on our erection methodology. So that is the way it has been constructed. And in terms of malls, if you take, we have Dubai Mall, which is 1 kilometer by 1 kilometer mall in Dubai in terms of sizes, and also the Mall of Emirates, which has Arabians' lateral thinking, where they have brought in Switzerland inside by having the skiing inside the middle of the desert, where 24 hours round the clock you have all the time 1.5 meter depth ice is always being maintained, and the people will be skiing there. And in terms of hospitals, we are right now doing a hospital in Abu Dhabi, which is Cleveland Clinic, which has 15,000 metric tons of structural steel involved inside, which has large span structures to take care of even, it is not the strength governing structure, especially here the vibration governs in this particular case. And how are they in sense is a commercial building is driven by, if you take, based on the extensive analysis on various buildings which we have constructed as well as across the world, which is mainly meeting the architectural demand. Most of the structures on commercial things are involved, not in India. India, there are structures which are coming in, where, say, here, most of the concentration is on iconic structures, where like the Capitol Gate, which is the most inclined structures, which we are going to see a few slides of that, how it is getting constructed. So those things are all really, really challenging, and it is possible only by constructing in steel, and RCC definitely would not have been possible. In terms of span, the major governing fact, as what earlier Mr. Turner has said, the long span structures, if you take, the obvious choice is structural steel, and as a commercial building, long span structures are very much useful in terms of modules of the the office modules, which can be in multiples, where instead of 9 meter, if they go to 12 meter or they go to 15 meters, they have a very efficient usage of the space. So column-free structures is really, really advisable, and commercial buildings are mainly going into that area and the choice is structural steel as an obvious choice. And in terms of rapid business expansion, where number of buildings are getting up, and quick delivery and easy occupation because of the quick delivery, all these things that is again related to timing. So the structural steel construction is almost half or maybe 3/4 of the construction of the concrete buildings. And also like mega events, if suppose if the country is undergoing an event like Olympics or Asia or FIFA, if you ask, Qatar 2022 is completely being equipped, or maybe they're gearing up with the structural steel buildings, stadiums, everything. So which in fact Qatar 2022, the speciality is all this 9 stadiums which they are constructing right now, is after the event is finished, they are going to completely dismantle and going to give those stadiums at free of cost to the third world countries. So that is their one of the main topic for winning the FIFA 2022, and also Commonwealth Games. So these kind of events also can influence the commercial buildings in terms of structural steel. And off-site fabrication, because that avoids the site congestion. And if you take Mumbai, where the site is going to be a major constraint, even there are towers which right now we are doing, which is 20 meter by 30 meter only the size of the tower, and we need to have almost about 8-meter excavation, and then we have to construct the raft and then proceed. So where the obvious choice is structural steel. In terms of flexibility, because the towers can be done either vertically, you can add up 2 floors if the FSI, because every chief minister when comes in the FSI changes and the number of floors goes up and down. So actually speaking, structural steel is one of the options where you can even just add up additional plates if it required at the bottommost layers if you are raising up based on to increase the FSI. In terms of horizontal attachment also can be done by with the structural steel option comparing with concrete. And the building being lighter when you are using structural steel, as earlier been presented, you know that how the column sizes have been reduced, which in turn influences also the foundation. And as an office building or a commercial building, the transfer or the open space is really required. For example, most of the buildings are being constructed with facade as concrete, as glass. So which may not be possible in terms of residential building. So in terms of commercial building, to go to that stage, structural steel plays a major role because lots of cantilevering is possible here. And also the fabricators with the state-of-art facilities who can do complete prefabrication outside, and they can bring it to the structures. And also the mindset, which is also a major area where right now still that we are not in a position to penetrate into the higher level in terms of residential building, in terms of structural steel. So these are the governing areas which we can foresee that the structural steel plays a major influence on the commercial buildings. And if you go back to, back to the projects which we have done, which is Capitol Gate. This is the most inclined building as of now in the world, which is a 33-story building and having almost about 9,000 metric tons involved inside, where externally it has been constructed with diagrids and internally also been with an atrium opening up from 14th floor to 33rd floor, which is also constructed with pipe structures inside. So very highly challenging structure. If you see the flow plate, or in other, if you see the pizza is about 14 degrees, whereas this goes to 18 degrees, and it is right now being registered as one of the world inclined one in the Book of Guinness Records. So if you see here, you can see that how exactly the core is being constructed. Core never have been inclined; it is vertical. Whereas the bottommost point, the core and the structural steel diagrid is almost closer, where you cannot even have a usage space. Whereas on the other side, it is about 33 meter going outwards. The same way when it middle, it is balancing, and at the topmost point, same case as the reverse, where the core and the structural steel diagrid is very closer, whereas it is cantilevering on the opposite side by 33 meters. So when we are doing this, in fact, core itself have been pre-cambered. If you ask me, they have moved the core by 330 mm, and it has been pre-stressed to take care of the counterweight when it goes up the top. So that is the way it has been designed. And if you see, complete Tekla model has been done by us on that. And if you see that it is one of the deck, which is the middle area. And this is the external diagrid alone, which is being done with the box sections at the base, 900 by 900 box of 80 mm thick built up sections, and when it goes to the top, the thickness reduces, the box size remains same, and it has gone up to 16 mm. And this is the actual structure which is constructed. And if you see the connections, any junction if you take, all the diagrids, there is no one single diagrid is symmetrical. All the diagrids, all the junctions are different. When it takes as a surface, there is no single plane meets also the other plane. That is the reason we have introduced the cruciform plates, which is at the middle to take care of the forces. So that is the way it has been done. So, and it is not really possible when you do that in concrete. And if you take the internal diagram, it is completely being done in pipes. And we have erected in segments like X, so that we just always face the pipe to pipe junction as perpendicular to that for easy construction at the job site. Because of the architectural reason, the entire jointed site is being done with welding. None of the areas the bolting is allowed. And we have at any point of time more than 30 plus welders who are highly qualified, 6G welders in the job site to do the job. And this is just progress of that. And this is the inner atrium, which starts from 14th floor up to 33rd floor. It is open. So inside of the office, you can see the direct sun at any point of time on the middle of the building. And of course, the other structures is also there, which is also strengthening the core and cantilevering. You see that at the middle, there is a cantilevering portion there, which is nothing but, this is the topmost portion at 33 meters. If you see that extreme right, say left edge is the place where the core is there, and it is getting cantilevered due to the inclination. And you can see that core with the jump form now. And where you can see that the cantilevering is happening, which is nothing but the swimming pool which they have done in the middle of the building, outside the building. And this is the progress of the project. The entire project with 9,000 plus tons have been done in 24 months, inclusive of our design. And here the major challenging thing is the design, detailing, fabrication as well as erection, all have been done simultaneously with just one or two floors in, say, up and down because of the geometry. Because when it goes up, the behavior of the structure has been taken up, and then as-built have been taken up when they do the reanalysis, and they will keep on doing that because the behavior of the structure, there is no symmetry there. Even it is not a circle, if it is not also an ellipse. So they were doing very closely with the construction team. So this is a structural steel building, which I can say that one of the marvelous structure in Abu Dhabi, which is there on the main road. That is what the swimming pool which you are seeing on the middle. And in fact, glazing has a tolerance of more than 75 mm, because when we are erecting, say for example, 15th floor, when we are going up at say 30th floor, the 15th floor is not in the same position as what we have erected. So the tolerance which they are following with the glazing is very heavy. It is not even 5 mm or 10 mm like any other building. The tolerance has been very high, and it has been accounted for 75 mm. So this is one of the structure which has a very good office usage space in terms of structural steel. Burj Al Arab, of course, you may be knowing that, which is a 7-star hotel access in terms of land, land, sea and air possible, and it is being done in the man-made island. The entire structure, as a structure, it is in concrete, but the stability of the structure, which is completely with the exoskeleton, and it is done only in steel. So outside, whatever that you are seeing as a curved member and diagonal member and horizontal member, all the members are just to make the structure stable. So this is the construction of the piece, and any point of time the piece weight what we have lifted is 25 tons. All are being prefabricated. And whatever that you are seeing on the middle is the scaffolding or the welding chair where the people have access there and welded. The entire structure is being welded in position. Because of the architectural reason, the bolts are not allowed, or it is being boxed. The bolt itself is very difficult to put up a joint there. So that is another challenging job, and it was the very first job for us in Middle East, and also for the UAE itself. It is the very first job to have its own challenges. And the diagonal, which you have seen that, which you are going to see, has been erected with this transjacking method by cantilevering outside the building. The weight of the structure, weight of the diagonal is about 180 tons, and the length is more than 3-4 trailers, and it has been say transported as a single piece in the entire, from the factory to the site. You see this, what you are seeing here is in the ground position, and that structure is being not assembled in the job site. It is being transported as one piece with the longest trailer, and when they were transporting, the speed of the trailer is about 5 km per hour, not more than that. So, and this is just in the lifting point, lifting condition. You can see that the pin, which is a single pin, the entire diameter of the pin is about 500 mm diameter, and it is, when it is getting inserted, it should not, in fact we have calculated the thermal expansion of the entire diagonal as well. And this is the erected point. And it is 3 diagonals on either sides, it's about, in total about 6. And the horizontal member itself is about 200 tons, which is being lifted again in the same methodology as the box. And what you are now seeing is the cantilever hotel, which is constructed on the same building with a segmental erection. You can see that the cantilevering is happening in the air. This is the under view of the same hotel, which is the Sky View Restaurant. It is about 70 by 25 meter size. And this is the helipad, which is about 200 plus tons, where the Andregas played the tennis over that particular helipad. So this is another structure which is completely of about 11,000 metric tons of structural steel involved in this in total. But none of the structure is with the floor plates or the columns. It is only for the stability of the building. The building is in concrete. And this one is Kingdom Trade Center in Saudi Arabia, where the overall height of the building is 300 meters. The last 120 meters is what you are seeing as like a needle hole, and it is completely non-occupant. All the 120 meters there is no floor. So the floors are only 180 meters, which is completely done in concrete. What you are seeing is the 180th meter. Over that only the structural steel comes, and all the 120 meter above is only for roof feature of the building, and it has only a panoramic view bridge at the top. So because there is no concrete on the 120 meter, the entire structure is subjected to wind and all the time in tension. It's because it does not have a counterweight to balance it. And this is the Tekla and Bokad model together. The bridge is done in Bokad and the entire other structure is done in Tekla. And at any point of time, in the bottommost necklace point, where the joint has 13 members together and 19 members at one particular joint. So if you see that, when we were there for constructing, when we were entering into the project, the tower cranes on either side have been fixed and the construction is happening, where the tower crane can lift only 8 tons maximum, whereas the bridge, which is going to be at the top, is 180 tons to lift as a structure alone. So we have planned in such a way, we have assembled on 188th meter, and then we lifted by having like two other side, we have taken up like a column, and then we lifted the middle portion with the bridge as what you are seeing now with the stand jacks. This is the way. And here also, the 120th meter when we start lifting, the entire column started buckling. So in terms of analysis, so what we have done is we have lifted in 2 stages at 60th meter, and we have strengthened the necklace bottom like this, and then we have lifted again to the next. And when we are doing in position, we have completely welded one side to allow the other side for thermal movement, and we have connected all the 4 joints again, 4 cards at one time, so that to avoid the differential movement of the expansion. So that is the way this has been constructed. And here also there is, even though we have used about 7,800 metric tons, none of the steel is used for the floor planes. It is only for the roof feature. And you can see one of the connections which has 13 member connecting at one single joint. And these are some of the connections where even you cannot apply any of the spreadsheets. It has been derived from the basic principles. And this is Kipco Tower, which is a standard building but has its own complexity, which is being in diagram. And this building is done in Qatar. And central circular core and the diagonal is the column and the perimeter. The span is 14 meters from the core to the end. So this 14 meters is really very much helpful in terms of an office to plan properly. So that is the reason they have selected structural steel for this. Even though there is one more neighbor building has been taken up in concrete. If you see in Qatar, there is one more building in concrete completely into similar diagram fashion. Whereas they have started 6 months ahead, whereas we have finished 6 months ahead. So that is the way that it has been done. And this is the in fact, even pre-assembly in our factory, we have done that whether the pieces are getting matching or not. And that is the way that we have done. We have done in our Dubai factory and we have transported to Qatar. And all the floor beams are having even MEP openings for the floor requirement. And it has the inclination from the bottom towards the center and opens up again to the top. So that is Kipco Tower, and that is an office building again. Tiara is another office building which is there in say Sheikh Zayed Road. One is the hotel tower, one is an office tower, which has again a central core and perimeter columns, and there is no in-between floor columns. So the span is about 14 meters in one side and 12 meters in other side. So which was very efficient in terms of office space. So they have gone for the structural steel option because of that. And also we have constructed well ahead in schedule, and we have used about 4 days cycle per floor to construct that. And Rose Rotana is another hotel tower which is right now in operation, but say we have done in a record time of 24 months, 75-story building. 30 meter by 30 meter is the floor print, and it has a core at middle width is only 10 meter by 10 meter. The entire column is not even composite because the space restrictions, they have gone for jumbo sections of 1080 kg per meter jumbo sections to make this column so simple and slender. So these columns are completely being used with, in fact even they have used the bottom with a cover plate to make a box, and later it has been just opened up and it is a rolled section. And it is a 30 meter by 30 meter floor print. It's a hotel. Have 4 transfer girders at the middle, and you can see in the middle that there are double-story transfer trusses and belt trusses to take care of the drift of the building. And the roof is again a steel. It is very elegant in terms of steel, but it is quite complex to have this kind of roof geometry. And this is the Tekla model, and the other side is the actual construction of the same building. And Snow Center is Dubai. In Dubai, it is a mall where as what I earlier said, between the two square core columns, the space is 54 meter, and across is again 54 meter, which is almost like a football ground. And the entire construction has happened with the trusses spanning from one side to another side, and in the same inclination, but one side starting at the ground, and it has been about 12 meters on the other side. You can see temporary supports being erected in the same height so that individual trusses can be supported. And during that time, we were cantilevering the other side with the temporary structures to make that truss. And this was the assembly in progress. And once that is done, even we have concreted the floor and cladded as well in the ground to avoid the latest scaffolding when it is in position, which is almost 70 meters above the ground. And we have used 4 towers on 4 corners, and each has 1,000-ton capacity synchronized jacks to lift the entire structure. When we were lifting, the structural weight is 3,000 tons. It is one single lift, 3,000 tons that we have done that, which includes of concrete and cladding. The structural steel alone is about 2,000 plus tons. So this is what the progress we can see that. So this is what, when it is getting lifted. We started the first day morning, and then we have ended up with the second day, in position. So it's about 48-hour operation to lift that, and then we were monitoring also the wind for almost about a month to see that when it can be lifted, when we were doing. So in terms of projects in India, we have done, airports, where about southwest pier and the mega columns have been part of ours. Even though it cannot come under commercial classification, just what we have done that I'm just putting it up. It's a 2.3 meter by 2.3 meter mega column which is being done with the plate built-ups. And Trump is another tower which is that's what initially I said that. Even now the developers have started inclined towards residential building in structural steel. This is one of the structural steel building in Mumbai, 67-story, which we are right now doing for residential building. Even we are, as what Kamal sir earlier told, in his presentation, we are using here slim floor deck, which is a deeper deck, to make sure that the depth of the beams are very limited because of the architectural impressions. So we are using that in this particular project. And Marathon Future X is actually a 44-story building, is a commercial building. And of course the power plant structure which we are doing this. In fact, when we are entering into Marathon, they have done about 5 floors with concrete, and internally that we need to erect structural steel. So it was quite challenging because none of the cranes that we can take it up for our material lifting. So we have gone with our old method, and then we have done this, which has metal decking as well as concreting together. And right now the structure is waiting for its next level approval. As earlier our friends have told, doing that in 24 months or 36 months is fine. But the problem what we are facing in India is approval on high-rise committees. So once, if it is very clear, construction of the building is not at all an issue. In terms of steel, we can do with say 3 or 4 days cycle for the structural steel columns and beams, and for the core with 6 days. Because the job which I am telling you earlier, the 67-story building, we are using first time in India with the jump form techniques, and that is going to achieve almost 6 days cycle of a core per floor. That is what we are aiming. So international technologies have been incorporated, and then construction is being started in India with that kind of thing. So time is not at all an issue. Whether say the proper the overall integrated things that whether we are looking at or not is the question now. In terms of fabrication, this is our Dubai factory, this is our Sharjah factory, and which has all state-of-art facilities. And this is having a pre-assembly yard. And in India, we are having a factory in Trichy, which has